and welcome to my channel again. So today we are going to the second video of this lecture series or the playlist I am creating that contains the problem which is not even solved or not yet solved on the YouTube. Today's problem is the Hamiltonian of 1D simple harmonic oscillator is given as you can see the general Hamiltonian, and we have to find this commutator bracket where h and x square first combination, and after that the result of this should commute with h, and we have to find the whole commutation bracket in terms of x square and h. So this is the main requirement in terms of x square and h, and the other thing is we have to compute the matrix element of this thing. Okay, so let us start with this problem. So at first we have to know two formulas regarding this solve. Okay, these are the most general formulas. Like if we have a p and we have a f of x here, and we want to calculate the commutator of this thing, we will get I h cut del f del x with a minus sign. Easy way to remember, if there is a position function or we are taking the derivative with respect to the position, there will be a minus sign. Okay, and if we want to take the other way around, like we have a x, these are the operators, okay, because we are in quantum mechanics, and if this is the f of p, we have to write g of p. You just don't get confused with these are the same functions, they can be different. Okay, so we will get I h cut del g del p. Okay, there is no minus sign for the momentum derivative. So these are the formulas we are going to use. So you don't have to expand the whole thing. At first we'll compute the small thing hx square. Now from here we can say that a commutation with itself will give me a big zero. So it does not make any sense. And p square can be written as p dot p because these are the vectors. Okay. And now we have another commutation relation we are going to use, that is AB comma C can be written as A BC plus AC comma B. Okay, this is another commutation relation we are going to use. So you can treat A, B and C, these terms respectively, and we can write okay. So yes, now you guys can ask a very simple question, that there is p square and x square, so why can't I just directly use that relation? Because you can see that this is p square and this is p, and we don't have any formula for p square, so we have to break it down into the single power form. Okay, there is no formula for p square. So for this I will get a minus I h cut, and I will get a 2x, and p is on that side, so 2I h cut and p x. Okay, similarly from here I will also get the same thing, minus 2I h cut, but here I will get x. Okay, so now if I take the minus 2I h cut common, I will get px plus xp. 2 will get cancelled out. And if I take the minus down here and write it as I squared, so then I can write, let us leave it like this. Okay, we don't have to make that much modification. I cut by m px plus xp. So this is our final expression for h comma x square commutation. And now we have to put this thing inside this. So now h comma minus I h cut by m px plus xp. This whole commutation we have to calculate. I have taken the commutation this and then plus this with this. Okay. Okay. Now, if you like, this is my way. This is not necessary that you have to do it, but this is my flow. So I will inverse this formula. I think you guys obviously know that a b can be written as minus b a. Okay. So by using this, I will invert the relation here. Totally just for my convenience. You guys can do it without doing it. So I will just take the minus inside and I will invert it. Okay. Now, I will again break this commutator as a plus b c, so I can write ac and bc. Okay. Okay, I think you guys can understand what I am doing. Leaving some space, I don't think I have to leave it here. I can in general write here if any other commutation relation I am going to use. Okay. So now see, this is A, B and C situation again. So now the other thing will get 0 because P with P square will give me a total 0. Plus again the same thing will happen, but here the X will be on the P will be on that side. Okay. Same thing will happen for here this case also, that for X I will get 0 with X square and for P we will get a non-zero value. It is very important to maintain the order because we are using the commutation relation in quantum mechanics. In classical mechanics, in Poisson bracket, these are finite. I can write them here and there. Okay, now xp square will give me just ih cut to p. So ih cut by 2m into, there will be a 2 also, 2 ih cut by 2m into p will give me just p squared. Okay, plus the same thing will happen here also. 2 ih cut by 2m, I will get a p square plus, now this will give me a minus ih cut. So minus 2 ih cut to x square. Okay, and from here I will also get the same thing. The minus is here due to this. Okay. So I can take the ih cut common out. So ih cut squared by m into 2 into p squared by m minus 2 into half m omega square x square. I can take the 2 common also. Okay, so after that we can write that I square will give me a minus 1. So minus h cut square by m, and I can take the 2 as common. So 2 h cut square by m and p square by m minus half m omega squared x squared. Okay, so you can see that I have to write this thing in terms of x square and h. H means the Hamiltonian. So I have to modify my term. So I can write minus 4 h cut squared by m to p squared by 2m minus half into half m omega squared x squared. Okay. So from here we can write p square by 2m plus half m omega squared x squared minus half m omega squared x squared and a minus half m omega squared x squared. Okay. Achha, I think I have written a half extra here because during this cancellation, yes, I missed a 2 here. So this 2 will get cancelled out with this 2. So there is no half here, okay? There is no 1 half extra here. And finally we can write that minus 4 h cut square by m, and this thing is just the Hamiltonian. So Hamiltonian minus m omega squared x squared. This is my required value. Okay, I will erase the board now, so I can do the next part. I will erase it in 3, 2, 1 now. Okay, so I have erased the board, and here is given that k and k prime are the energy eigenstates. Okay, it is not given on the question, but you guys I think already know that. Now if I have to compute this thing, at first you have to write the what is x for a simple harmonic oscillator, which is basically no. Root over h cut by 2 m omega into a dagger plus a. Okay, but a dagger is the creation operator and a is the annihilation operator. So from this we can write, if I take the x square, okay, so this can be written as okay. So now we can write as, like, if a dagger is going to operate here 2 times, then I will get k prime plus 1, k prime plus 2, okay, within root, and k prime plus 2. Fine. After that, if a is going to operate on k prime twice, then root over of k minus 1, sorry, k prime minus 1, k inner product with k prime minus 2. After that, we know if a dagger operates on k prime, we will get a k prime plus 1. And after that, if a operates, we will get again a k prime plus 1. So the root will be ruled out and we will get k prime. Okay. And this a dagger is just a number operator. Okay. So we directly can write that it will be giving us k prime with k dagger. not dagger, sorry, k prime. But we have no idea if k prime equal to k or k prime plus 2 equal to k. So in general we have to write this relation using a Dirac delta function. Not Dirac delta function but Kronecker delta. Sorry. Obviously this expression can be reduced, but as no further condition is given, so I am just keeping my term till here. I have just combined these two terms and have written 2k prime plus 1 as delta k prime. So as no further conditions are given, this is our final answer. This is pretty easy. Okay, I think you have understood the problem, and thank you for watching.